Hello, my dear students. So, welcome back to the St. Joseph Composite PU College, Bijapur. I'm Rahul, chemistry faculty, and in this video, I'm going to discuss the methods of expressing the concentration of solutions. We have started discussion of solution topic. We have seen that types of solutions, and we have taken the different examples for different types of solutions. Now, this is the second part of the topic, that is methods of expressing the concentration of solutions. There are various methods we can use to measure the concentration. So let me start with first. The first one is the mass percentage. Mass percentage. Second one is volume percentage. Volume percentage. Third, that is the you can say that mass by volume percentage. You can take. Okay, let me take mass by volume percentage. Volume percentage. Fourth one is that term is used for the calculation of concentration of any of the solute which is present in very small quantity, that is ppm, parts per million. Okay, then fifth one is, as usual, as you studied in the 11th standard, that is molarity. It get repeats once again. Sixth one is molality, and the seventh one is normality. We have to discuss this normality because this is very important term, and when we study the normality, we have to study the equivalent weight and equivalent masses and all, and number of equivalents and all. And eighth one is formality. And after this, okay, normality, molarity, we got okay, one more we left, very important, that is a mole fraction. Actually, this entire topic is dependent on the mole fraction. We have to concentrate more at the mole fraction, molality. Okay, so these are the two important concentration terms are there which are frequently used in this topic. Let's understand the first one, that is mass percentage. The first one, that is mass percentage. Very simple concept is there. What do we have that? Assume, just let me visualize this with an experiment. Assume this is a container, and in this container you have taken a certain amount of solution. Okay, solution. The total amount of solution is there. No, it should be 100 gram. 100 gram of solution. 100 gram of solution. Okay, in that you are added a certain gram of solute. A certain gram of solute is added. Gram of solute. Solute is added. When we add gram of solute plus a certain x gram, let me take it, x gram solute dissolved in certain amount of solvent, and together when we combine solute and solvent, the total weight of the solution should be 100 grams. This is very important part. We are not taking a 100 gram of solvent, we are taking 100 gram of entire solution, which includes solute plus solvent. Okay, therefore if I want to calculate the mass of solvent, let me write mass of solvent, we can write like this: mass of solution minus mass of solute. Okay, this is what we have. Okay, now we'll take the definition for this. So we can write the definition: the mass percentage of solute can be calculated like this: the mass of the solute, and whole divided by, we have to divide this entire mass of the solute by mass of solution, not a mass of solvent, and that should be multiplied with 100 because it is the percentage. Okay, now we can provide a definition for this. The definition we can write like this: the mass of solute in grams. The definition we can provide like this: mass of solute that we have to express in the gram, mass of solute in grams, dissolved in the 100 grams. We have to take the total mass of the solution should be 100 grams of solution. 100 grams of solution. And remember that the solution should be here homogeneous. The solute and solvent together mixed and form a uniform, you can say that, concentrations. Now let's take an example. We visualize with example. Now what we have that certain, let me take a container. Okay, in this container, a certain amount of solution is there. What we are saying that the total, you can say that the percentage of the solution solute in this is 10%. Okay, let me write complete problem over there. What they are saying that calculate the mass of sodium chloride. Calculate mass of sodium chloride. Chloride. Okay, we have to calculate the mass of sodium chloride that should be dissolved. That should be dissolved. Here we are using the 45 gram of water. Means we are taking here mass of solvent is there, mass of water, to obtain 10% of solution, 10% of solution of sodium chloride, that substance. Try to understand this. What they are saying that, so they added a certain amount of x gram of sodium chloride is added in the container. And already the water they have taken, it is around 45 grams. This is a 45 gram of water is taken. Mass of solvent is given, but mass of solute is not given. That we have to calculate. But they given that what is the percentage of solution is given. We'll write that once again. The mass of mass percentage of sodium chloride, NaCl. Let me write once again NaCl, and then I'm going to write here formula, the mass of NaCl, that is actually x, which is not given. We have to calculate that. Then mass of solution, and that should be multiplied with the 100. That is the percentage. The mass percentage is 10% is given. That is the 10%. That equals to mass of the solute, that is sodium chloride, it is x, which you don't know. We have to calculate that. Then mass of solution is given, and mass of solution means it's the mass of solute plus solvent. The solute is x, but solvent is 45 grams. Therefore x plus 45, and that should be multiplied with 100. Okay, let me simplify this. This 0 and this 0 get cancelled, obviously. Then x plus 45 is equal to 10x. Okay, so now again let me take you over here. What will take? It's a 45. I will take x on the other side. The 45 equals to 10 minus, that is 10x minus x. Obviously it will give here 9x. Okay, 9x equal to 45, and x equals to, we get here, yes, 9 divided by 45 divided by 9, right? We'll get here 5 grams. 5 grams we get. Okay, it means that to get a 10% of the sodium chloride solution, when the water is 45 gram, and 5 gram of sodium chloride should be added. Therefore we can write the conclusion here. The 5 gram, no, we got answer is 5 gram. To obtain 10% of solution of NaCl, have to dissolve around, you can say that 5 gram in 45 gram of water. 45 gram of water. Okay, this is all about the mass percentage. We'll see the same kind of definition for the volume percentage. That is the second one. That is volume percentage. So volume percentage have very simplified, you can say that it is very simplified definitions, because in the volume percentage means both the solute and solvent should be in the liquid state. The solution, whatever the solution we have, that should be liquid. Let me write that. Here the solutions of liquids are commonly expressed in the volume percentage. So whatever the solution is, solution or liquid solutions are generally expressed. Liquid solutions. This is used for the liquid solutions. Okay, there's one part. And what they are saying that the volume of solute. Okay, let me write. It is defined as V volume, or volume of solute dissolved in 100 cm cube or ml, cm cube, or you can use ml of the solution 100 cm cube of the solution. It is also same way of visualization is that we have to take a container. In this container, total volume of the solution should be volume of solution This should be a very interesting student. Volume of the solution should be here, that is 100 ml, 100 ml, or you can write 100 cm cube. Okay, and in this you have to add a certain amount of x ml of solute, and solute also here it should be a liquid. Okay, whatever it is, liquid or solute, whatever. Now we can provide a formula for this. Volume percentage can be given here as the volume of the component, okay, and that should be divided here, and that should be divided by the volume of the solution, and that should be multiplied with the 100. It is same as the, you can say that same as the mass percentage. We can write the same kind of problem for this. You have to calculate the answer and provide the that answer in the comment box. Let's see what we have. Example, you have to calculate this. It is a challenge for you students. You have to solve this if you understood this. Assume that a 10 ml of alcohol is dissolved. Okay, I don't want here 10 ml. Let me write here x ml. A certain ml, that's take x ml of alcohol dissolved in 100 ml of solution, 100 ml of solution, 100 ml of solution, and the mass of solvent is given. Mass of solvent is 45 gram. In order to get 10% of solution. Okay, this is quite challenging for you students. If you have understood this concept, whatever I taught in this video, if you understood this, you please solve this, and please you write the answer in the comment box. It's a little bit challenge. You have to find the x value, the x amount of alcohol. You have to find out how much how much ml of alcohol should be dissolved in 45 ml of water to get 10% of solution. Let's see students. Thank you for watching this video.